Okay, so we're going to start on example 8, and I want you to take a look at this one right here because mine looks a little bit different than yours because what I did was I actually whited out the z because on examples like this where you're given the angle bisector and you're given one triangle, all right, they're not always going to tell you which side length is going to be the one that has the variable. But the thing is it doesn't matter, all right? You could really assign whichever segment, all right, the variable, okay? What I tend to like to do, though, is just to select the top one, all right? So I'm going to let this one be my z, which is what you guys have on yours, okay? And then I'm going to call this other segment 32 minus z, okay? Now, you could have switched these around. Like if you wanted to put this one as z and then the other one as z, as 32 minus z, that's fine. All right, it's not going to affect your answer. But let's start with finding the scale factor. So the scale factor is going to be the corresponding sides, the other sides. All right, so I'm going to do 15, all right, is to 9. All right, so 15 is to 9. All right, and if I reduce that, I'm going to get 5/3. Okay, so getting 5/3, I'm going to now match up the corresponding segments. So because z is adjacent to the 15, that's going to go on the top. And then 32 minus z, oopsie, that down. 32 minus z is going to go on the bottom. Okay, so I'm now going to cross multiply. All right, and when I take that 5 and distribute it through, I'm going to get 160 minus 5z is equal to 3z. All right, adding that 5z over, I'm going to get 160 is equal to 8z. And then if I divide out that 8, I'm going to get z is equal to 20. All right, so once again, you're not always going to be given the variable. You can assign one of those segments to be the variable, and then the other one is going to be the difference between the full length and then the other segment. Okay? I'm just going to do one more of these, all right, because then the other ones are very similar to the ones that we did on top, okay? I'm just going to do the next one. So let's go ahead and notice that that's an angle bisector, all right, which means that this one is 18 minus x. All right, setting this up, I'm going to do 6/14 is my scale factor, which reduces into 3/7. So then I'm going to start with 3/7 equals, all right, and then x is going to correspond with the 3, and then the 18 minus x is going to correspond with the 7. All right, so cross multiplying, I'm going to get 54 minus 3x is equal to 7x. Add the 3x over, so 54 is equal to 10x, which means that x is equal to 5.4. All right, so for the last two, if you want to do them on your own, all right, for this one right here, I actually got x is equal to 12/7, and you can change that into a decimal if you want to. And then this one right here, I'm going to get x is equal to 8.4. And then for the last one, it says, consider the triangle formed by the path between a batter, a center fielder, and right fielder as shown. If the batter gets a hit that bisects the triangle at angle B, is the center fielder or the right fielder closer to the ball? Explain. Okay. So what you need to look at is the fact that this angle bisector right here, okay, is splitting this segment into proportional segments based off of the other side lengths. So what I want you to look at is the fact that the center fielder has a bigger distance, right, than the right fielder. All right, which means then that if the center fielder has a bigger distance than the right fielder, then this segment right here has to be greater than this segment right here, okay? Because it's proportional based off the other sides. So the answer to this one is the right fielder. Ooh. Okay, so we're just going to end there, all right, for your notes. I think it should be a pretty understandable lesson, but let me know if you have questions.